I I will represent with Neti Norda.
Oh, okay, okay. So the second paper will be presented by Pak Iqbal. And the third one, uh, the third one should be Mr. Akas Poptani. Is there any?
Hello.
Yeah.
Yeah, so I am one of the authors for that paper.
Okay. So you will be the third presenter, right?
Yeah, yeah.
Okay. Okay. And second and third is okay. The fourth one should be Somesh Sharma. Hear it. The fifth will be Pak Iqbal as well. And the sixth one, Purna Sulasteputra. Okay, let us wait for another few minutes. If they are not here yet, then we can start with the second presentation. Let me check the main room first. Okay, since Pak Yudo is here already, Mr. Yudo Haryadi. Hmm.
Good
You should be
afternoon,
the first
madam.
presenter.
Yes.
Okay, good afternoon, everyone in the room. Today we will start the first session of the second day with the title of Oceans and Atmosphere Applications. As a first presenter, with a paper titled Mapping and Characterization of Seamounts in the Flores Sea using Acoustic Remote Sensing and Gravity Core Technology. This paper will be presented by Mr. Yudo Haryadi. Pak Yudo, are you ready?
Yes.
Okay. You have 20 minutes to present your paper, include a question and answer session. Please start, Pak.
Thank you for this time, Dr. Endang. Prepare my presentation. Thank you, Chairman, for your kind introduction to me. And good afternoon, ladies and gentlemen. My presentation title would be Mapping and Characterization Seamount in the Flores Sea using Acoustic Remote Sensing and Gravity Core Technology. This my outline presentation consists of introduction, objective, methodology, result and discussion, and conclusion. This introduction. The global battery metal forests sea are very varied and have many different in depth, and there are high level that are isolated from the surrounding area. Like in this picture, we choose the area in this area, the red box, and geology and tectonic of the Flores Sea has the potential to encounter seamount and mineralization. The Flores Sea is a geology dynamic region with a history of significant volcanic activity. And the volcano around this region have been recorded to have erupted in the entire geology history. This geology activity can indicate the potential for seamount that have not been identified previously. Volcanic activity that occur in seamount can cause mineralization process. During an eruption, mineral-rich volcanic material is released to the surface of the ocean and can be deposited on the seafloor. And chemical process associated with volcanic activity can affect the physical and chemical condition of sediment around seamount. This picture image tectonic and structure condition in Flores Sea. So in this aim, two map characterization of seamount in Flores Sea have objective in mapping seamount in the Flores Sea. To characterize the surface of seamount using multi-beam echo center data, and three, identifying mineralization at the seamount. A methodology. We use multi-beam echo center for acoustic data was carried out in Augustus 2021 using research vessel Barunajaya 3. In research vessel Barunajaya 3 installed multi-beam echo center Kongsberg AM 304 with 1 by 1 degree angle. And we use Bullenberg gravity core for take sediment sampling. Methodology for processing data. We process data, bathymetric data, and backscatter data use carries. and carry ships backscatter for backscatter data. And for layout and dam analysis, use RGS and global mapper. For sediment analysis, carry out using XRF and megascopic analysis. This is a result and bathymetry result and morphometry section. We found the Simon in the Floresi with dimension around 1,500 meters, and with area 35 kilometer. The volcano, the Simon, is concept with relative steep slope around 50%. This morphology from bathymetry data. In general, the Simon as a concept with the main peak at relative point C location. This peak of Simon. The peak is at a depth of 1,000 meter below the mean sea level. There's the other high peak located with depth of 1,200 meter mean sea level, below mean sea level, and this other peak. We analysis the second peak. This from the C peak from main peak and this area is slope affecting deformation process. This the big Q deformasi process from C to D with E slope, and this peak deformation from C to this word with G slope, and the M area is this is area to slope moving sediment to from the top to the bottom. This result sediment. This is the result for first coring sample. The result sediment collection from two locations around the peak of the seamount revealed in interesting phenomena. At the first sediment sampling site, CR1, sediment sample show predominant of coarse sand size particle. See figure. Interestingly, there is a high potential for iron mineralization. This amount of iron mineralization in this sediment at this location. This is CR1. Next, yes, sorry. Sorry, the presentation not move slide ya.
We still have the sediments of coring sample number 1, Pak.
Number 1.
Yes.
Number 2, we cannot move from my computer.
Probably
Maybe have a problem with network, Bu Endang.
Or you
we
can try stop
Yeah.
sharing first and
Yeah.
then reshare it.
Yeah, we can stop sharing. Sorry,
Stop
Bunda.
and then reshare. Sometimes it happens, but apparently the time is ticking. Okay.
Okay, thank you, Bunda. However, at the second sediment sampling, at CR2 location, at the peak of Simon, sediment with slightly different characteristic, we reveal these sediment are dominated by large sediment, gravel grain, and this is the same mineralization, iron mineralization, but the core sample 1 more interesting than core 2. The finding indicate the complexity and diversity of the underwater geology of the study area. It is exciting to continue to understand the natural phenomena hidden with the depth of the ocean. This is a result of sediment. The table shows the result of mineral sediment collection at 2 locations around the top of the Simon. At the first location of the CR1, sediment sample were obtained with a dominance of quartz sand with a fairly high potential for iron mineralization. While at the CR2 location at the top of the Simon, sediment are dominated by gravel grain with intensive potential iron mineral also. This result and backscatter. The backscatter mosaicing from the processing state was classified into four acoustic class. Class 1, more than -9 dB. Class 2, -9 to -20 dB. Class 3, 22 to minus 30 for TB, and class for minus 35 to minus 48. It can be seen from the figure that the distribution of backscatter intensity has a spread distribution. Although the range of backscatter value is relatively short, the acoustic class 1, which is color coded with a brown color, dominated the southern area, especially on the southern ridge, which extend from west to east. The acoustic class 2 is represented with a yellow color, which is evenly distributed, dominating the Simon area. The acoustic 3, which is marked in green, is distributed in spot from the top of Simon toward the north with a fairly dominant distribution, while the backscatter intensity class of 4 barely appear. If referring to Pratomo et al. 2018, the backscatter intensity class 2 can be interpreted as a boulder. This is a Pratomo boulder, while the backscatter intensity class 3 is interpreted by gravel. That it can be topic of discussion that the intensity class 1 can be interpreted as rock outcrop. If we related this finding to the result of current sample CR1, which is dominated by sand with a little gravel. The name sandy gravelly, and the area dominated in yellow color. Maybe this interpretation can more deep discussion.
You still have 2 minutes, Pak.
Yeah.
Can you
When the
finish
CR
it quickly?
one sampling location is located at backscatter class of 3, while the CR2 sampling location is located at backscatter class of 2. As a matter of discussion, it can interpreted that the backscatter class of 3 at the Simon surface is dominated by sandy gravel sediment, while the backscatter class of 2 is dominated by gravelly sand. We directed to a conclusion. This study is suited to identification the Simon of the Floresi, and quantitative characteristics of the seabed surface can provide an overview of the morphometric and morphology condition of the Simon. 3. Sediment analysis from the result of taking gravity core sample can provide information on the presence of mineralization at the location of the Simon peak. By using backscatter analysis, this research enabled to interpretation of mineral distribution. Overall, this research can provide very important information regarding the discovery of Simon and the potential for mineralization in Simon in the Floresi. Thank you, Dr. Indang.
Okay. Thank you very much, Pak Yudo. 1 minute. I give I give the floor to ask probably one question is okay. Is there any question from the audience? Not yet. If there is no question, one question from me. Can you explain or give an idea the main differences between your work, your research with the reference that you use at the three slides, the last three slides probably, work by the one from 2018 probably. Yeah, Pratomo. What's the main difference between your research and the work that has been done in 2018?
Yeah, thank you, Dr. Endang. Yeah, this uh, uh, this classification by Pratomo 2018. This backscatter intensities, and we found different still few different with the Pratama classification. Uh, we have we get backscatter intensity backscatter in class 2 and 3, and we found sediment at CR2 and CR1 like this. This is CR2 with dominant uh, dominant green, this CR2, and CR1 dominant green, and CR2 dominant yellow. And we get sample at CR2 dominant gravel, and at CR1 dominant gravel. We interpreted in my classification follow the in situ sediment.
Okay.
Itu. Yeah.
Okay. Okay, thank you, Pak Yudo. Thank you very much for your presentation. Big applause from us here in the room. Yeah, from Pak Iqbal also. Okay,
Thank you, Lita.
thank you. And then we can go through the second presenter for today, and that is Pak Iqbal. The second paper is titled Monitoring System Carbon Emissions Based on Land in Riau Province. Please, Pak Iqbal, you can prepare and start the presentation.
Then
Pak Yud, yeah.
Then I make a slideshow. Okay.
Okay, you have 20 minutes, include the question and answer session. The time is start.
Okay, thank you very much for the committee and the organization, AGERS conference organization. So I'm representing my colleague that cannot be presented today. So the research is about the monitoring system carbon emission based on land in Riau province. So this is the paper code. So I'm Muhammad Iqbal Habibi from the National Research and Innovation Agency. So the content will be concluded in the whole section. So introduction, methodology, results and discussion, and conclusion. So first of all, the introduction is first is the natural climate change. Climate change mitigation is considerably facilitated by the significance of the carbon storage found in the peatland. So the peatland covers 3% of the Earth surface. They can store about the 2,000 gigatons of carbon dioxide. So this is mentioned is twice as much carbon as forest. So 30% is a terrestrial carbon, 75% is a total carbon in the atmosphere. So the carbon content forest is determined the estimation of the forest biomass since the carbon can up to 50% of biomass in the forest. So photosynthesis in the forest binds the carbon dioxide can store this as a biomass. So like a tree biomass and undergrowth, litter, dead wood, soil organic matter is the primary carbon source as in the forest ecosystem. So this measure quantity forest biomass can potential reserve as a evaluating carbon forest reserve. And also, lastly, the faster photosynthesis that I mentioned before can take place more efficiently. Carbon is absorbed, so it can be better as a in environment for plants. So the methodology I took place in the Riau province. So it is in the central Sumatra. So it covers 9 million hectares and heights about 1,200 meters. So the natural forest key component is include the marsh, mangrove forest, primary and secondary dire land. So Riau mentioned can be the fastest deforestation in Indonesia. So most of it is they have oil palm, acacia, coconut, rubber plantation that can be expanded and converted in this island. Okay, so the second is the system monitoring emission of carbon that we built. So first is we build the land cover that we built using the WebGIS. So based on the land and based on land that calculate the carbon emission for the Royal Province. So the classification in WebGIS include the primary forest, secondary forest, primary swamp forest, secondary swamp forest, and last is the secondary mangrove forest. So second, we show also the peatland in our WebGIS. So we determine the carbon compounds of this carbon dioxide and monoxide is by calculating the peat emission by this formula. So emission factor times 2. So when we calculate that, we can get the peat emission factor. So each classes can calculate finally calculate the emission factor using the formula before. Third is the stock. We also show the stock carbon also by focusing from the IPCC reports 2003 using this second formula, then 2006 by using this third formula. So by formulating lastly by 40% of IPCC 2006. So the formula carbon stock is the biomass times 0.47. So the result and discussion. So this land cover examine the impacts of land change using the GIS and remote sensing. And then this we measured from 1990 to 2018. We cover 7 years in that, but we show significant in 2003, 2011, and 2018. So we can see that the secondary forest conversion is decreasing since 2012 in next figure. So this first one is the 2003. So first all the forest in dark green has populated in 2003. Then it in the 2018 the land is converted in some part of the area. So by different plantation in this area. Okay, next is the peatland region. So the peatland, this area is covered in the upper Riau. So it can be made in the 11 district like Indragiri Hilir, Indragiri Hulu, Bengkalis, Sampang, until Siak. This is the region that cover the peatland. So then some purpose that peatland has used for the conservation forest, industrial forest, and food crop forest in this reference. And then we, from that peatland, we calculate the above ground biomass or AGP and peat. That we conclude based on the IPCC 2006, 13, and 14 that we can conclude by this year. Then for this tons is we measure it by the region area in each district. So Bengkalis, we get the tons. Indri until the Siak, then we can get the area for this carbon emission for tons. Third is the carbon stock. So the carbon stock is we measure all the region of the area of province. So we can monitor the WebGIS emission by this system. And then meanwhile, after building the WebGIS, we also calculate the carbon stock. So we saw that the highest carbon stock is located in Pelalawan, and then the lowest is stock in the Kampar. So okay, uh, while we calculate in our GIS, WebGIS. And then we can conclude the this research. So this monitoring initiative highlighted need a sustainable land management methods. So by interacting the human activity and the carbon emission. So we studied from the land in the Rio province that contribute for the monitoring carbon emission. So in table 2 before we calculate the demo the IGP and PIT that this contribute yearly rise in total emission. So especially in the Bengkalis, in the Hilir, Indra Gilir Hulu, until Siak has the highest rate, so about 48.28%. Then the large difference is next is the Rokan Hilir district, 48.02, and Pelalawan district, 48.08%. Then each year, the carbon stock is remains steady. And Pelalawan, I mentioned in table 3 is the largest stock, and Kampar is lowest stock. So hopefully this monitoring strategy can assist the government and stakeholders identifying the changes in the region as preserving the carbon store and amount of peatland cover for local climate change mitigation. Okay, thank you very much.
Thank you, Pak Iqbal. 10 minutes. We have still 10 minutes time. Please, if anyone in the room will raise any question to Pak Iqbal. Is there any question? You can ask directly or you can raise your hand first. Okay. Uh, if there is no other question, any question, I'm interested to have a look at back to one of your table, Pak Iqbal. There is a table that stated, I can't remember. The table where there are, okay.
This one?
No, much further, bit further. Yeah, that one.
Okay. Okay, thank you.
Would you please put on slideshow, please?
Wait a minute. Okay.
Yeah. Uh, the ones with zeros there. Does it means that you didn't do the measurement over there, or what happens?
I I measure it, but there's something problem in this area, so I perhaps I will calculate it again. So
Uh,
and 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 also it's because when we calculate by the system,
mhm.
this area region calculate something zero. So maybe we
Oh, okay.
but because the other area is
Yeah, that makes me interested to me because if I assume that all the regions over there that you measure, it's like array of location where you do the measurement, right? But
yeah,
why all these four three
yeah,
three
uh,
places are zero, or
yeah.
maybe there are special reason for that, or yeah, or probably yeah.
Yes, I
Okay.
don't know, but when we measure by our WebGIS system,
Mhm.
the measure is zero. For some,
And it always happened, right?
yeah, it's always
Starting in 2003, 2011, and 2018, they're
yeah,
all the same result. They give the same result. It's always zero.
yes,
That's
yeah.
yeah,
Maybe
yeah.
we have to look at this. Thank
Yeah.
you.
Probably there is a special reason for that. I don't know, but yeah, it's good if you can look at it.
Yes,
Yeah.
thank you for your feedback.
Okay. Is there any question? We still have 6 minutes time. Okay, then if there is no other question, thank you very much, Pak Iqbal,
Thank you.
for your presentation. We can go through the third one. You come back on the fourth presentation, right?
Yes,
Let's go
after.
to the, yeah, let's go to the third presenter first. The third presenter is coming from the paper with the title Decoding Drought, Embracing Simplicity in Effective Predictive Models. Miss Akas Poptani, or yeah,
Yeah,
okay.
hello everyone.
Okay,
Uh,
thank you very much.
yeah,
Are you prepared for, are you ready for
yeah,
PowerPoint?
sure. We are ready
Okay,
for the presentation. Yeah,
so you have 20 minutes, include the question and answer sessions. You can start your
okay,
presentation now, please.
okay. Thank you so much. Hello everyone. Me and my co-author Sally Lokhande are here to present our work, Decoding Drought, Embracing Simplicity in Effective Predictive Modeling. So, according to a European technical report, which is cited here, rising global temperatures is linked with the heightened levels of greenhouse gases in the atmosphere. And this plays a pivotal role in influencing the climatic patterns. It influences both the occurrence and the severity of droughts. Therefore, early detection of drought is crucial for the implementation of effective mitigation and response strategies. It empowers the authorities to start water conservation measures, allocate resources for relief efforts, and provide timely assistance to the affected communities. This proactive approach is instrumental. This proactive approach is instrumental in minimizing the social and the economical impacts of drought. It promotes resilience and it ensures sustainable management of water. Drought results in water scarcity, impacting agriculture, economy, and ecosystem on a large scale. Machine learning and artificial intelligence can play a crucial role in transforming agriculture by providing inventive solutions to diverse challenges. Machine learning can analyze extensive satellite datasets such as satellite imagery and sensor data, delivering valuable insights to farmers regarding crop health, soil condition, water usage, and patterns associated with healthy and diseased crops. Therefore, we use machine learning and remote sensing in our work to predict droughts. Yeah, the next slide, please. Can you move to the next slide, please, Siley? So we utilize data from the AVHRR satellites. AVHRR is Advanced Very High Resolution Radiometer. These satellites are equipped with multispectral sensors, which offer rapid revisit time and deliver high resolution images across 6 spectral bands. We specifically utilize the first two bands, the band 1 and the band 2, which represent the red and the near infrared bands. We utilize, for further processing, we utilize the functionalities provided by Quantum Geographic Information System, QGIS software, to crop the data pertaining to our region of interest, which is Rajasthan. So the region of interest that we have chosen is Rajasthan. That is because of the diverse and contrasting geographical location. The data which we have recorded is available openly in the Star NESDIS website, and we have taken the data, we have recorded the data from 1981 to 2022, which is recorded weekly. This data is used to get the NDVI images, which are further used to get the VHI. VHI is Vegetative Health Index, and we time shift these VHI values for our analysis. The shape of the NDVI images that we have obtained after the after QGIS processing is 192, 256, 1. Next slide, please. Then we get the land surface temperature data from Landsat 8 website. From the website, we get high resolution information at the spatial resolution of 30 meter per pixel. We scale these data, we convert them to Kelvin, and present them as 192, 256, 1 images. So finally, we have seen in the diagram, we have seen how we get the data from how we get the NDVI data from StarNetSys, and then we get the VCI data from NDVI data. VCI is Vegetative Condition Index. Similarly, we get land surface temperature data from Landsat 8 website, and the temperature condition index data from LST. Finally, we get VHI values from VCI and TCI, and the shape of all the images presented here, NDVI, LST, VCI, TCI, VHI, it is 192, 256, 1. So now I'll speak about how we get the values of VCI, TCI, and VHI from NDVI. These are the formulas here that we use to get the values of VCI, TCI, and VHI. To get the values of VCI, we take the normalized difference from the minimum NDVI value, normalized difference of NDVI from the minimum NDVI value. For the TCI, we take the normalized difference from the maximum land surface temperature value. VHI is a linear it's like a linear combination of VCI and TCI values, where VHI is supposed to be A times VCI plus 1 minus A times of TCI. Here we have considered both the alpha and the beta, and which is A and 1 minus A, as 0.5. So that was data set 1 for us, which was the VHI data set. The data set 2, which is chosen by us, is VHI plus rainfall. So to get the rainfall data, there's an open source portal of climate research and services, which is at Indian Meteorological Department in Pune, IMD Pune. It provides precipitation data in gridded net CDF format with a spatial resolution of 0.5 degrees into 0.5 degrees. It is obtained nearly from 7,000 rain gauge stations. It is obtained for a period of 1981 to 2021. This data undergoes 2D raster image dataset through GIS-based operations. This process involves converting pixel values for each latitude-longitude pair into a single pixel value to achieve a 2D array format. Subsequently, please go to the next slide. After converting into the weekly format, we align the rainfall data with we can see in the right side of the chart. After converting it to the weekly format, we align the rainfall data with the VHI dataset using the functionalities provided by QGIS, which is resampling, reprojecting, interpolation. And after that, reshaping, padding, and normalizations operations are performed. The resulting raster image dataset encompasses key attributes including latitude, longitude, rainfall, and time. It provides a comprehensive representation of the gridded precipitation data. Further processing, finally after processing, we convert it to 192,256,1. So we have the VHI and the rainfall data of the sizes 192,256,1. Just similar to VHI, we time shift rainfall values. We time shift rainfall values also to we time shift rainfall values also to for an analysis like one time, two time, three time, and four time for analysis of 1, 2, 3, 4 weeks. To merge both the data sets, we have both the images in 192,256,1, and then we merge them together to get an image of 182,256,2. This kind of data is used for almost all the models apart from MLR. We'll shortly explain why we do that. Yeah, coming to the integrated system models. The integrated system model here, in the integrated system model, we can clearly see that the VHI data for the linear regression model, it is first flattened. So VHI data is flattened, rainfall data is flattened, and then we have inputted the flattened data together to the linear regression model. But in case of all the other models, first we merge these data, VHI and rainfall data, and then we flatten them and then feed it to the other models to get the outcome. Here, my friend Saili will further explain the models and the analysis.
Thank you for handling the presentation, Akash. Hello, everyone. I'm Sally Lokhande, a co-author of this paper. I'm here to talk about the models that we are using in this paper. So the models are as follows. I will first go on to the. I'll first talk about the first model, that is multivariate linear regression. The mathematical expression for multivariate linear regression is as shown in the slide. This is a common equation for the MLR model. Now, how we use it as is for dataset 1, X1 is taken as the VHI image data. The pre-processed VHI data is fed into the model as X1 for dataset 1, that is VHI dataset. For dataset 2, that is VHI plus rainfall, we feed in X1 as the VHI input data, while X2 is the rainfall image data. This is done across all the 4 time scales. All the 4 time scales were explained by Akash by time shifting the VHI labels by 1, 2, 3, 4 respectively for 1 week, 2 weeks, 3 weeks, and 4 weeks. The next model that I am going to share insight about is K nearest neighbors, that is KNN. How KNN works is it calculates the Euclidean distance between 2 data points. We then identify the K instances with the smallest Euclidean distances. Finally, we predict Y output, that is our target variable, by averaging the values of its K nearest neighbors. This process is followed for both the data sets, that is VHI, as well as VHI plus rainfall. The next model that I am going to talk about is the multi-layer perceptron. For dataset 1, there is a sequence of layers that has been followed for multi-layer perceptron, which encompasses activation functions like ReLU as well as mud activation function. For dataset 1, we incorporate only the VHI values, while for dataset 2, we incorporate VHI as well as the rainfall values both. We can see from the equations that V out and V out is the weight matrix and bias for the output layer. W and V is the weight matrix and bias for the hidden layer, while number of hidden layers is represented by P. The W1 and W2 are the weight matrix for the input layer corresponding to VHI and rainfall, that is the merged dataset. The next model is multi-output support vector regression. The mathematical formulation of SVR is as shown in the slide. We calculate this to minimize the loss function so that the final output is closest to the actual output. Here, beta is the coefficient matrix containing the weights assigned to the support vectors. H is the kernel matrix that represents the similarity between the pair of data points. U is the prediction error, which is calculated using Euclidean norm of the error matrix, while L is a slack variable penalty term, C is the regularization parameter, and LP is the cost function that we need to minimize. In SVR, we find a hyperplane such that the distance between hyperplane as well as the data point is minimum. The next model that I'm going to share insight about is one-dimensional convolutional neural network. The sequential application of layers in the one-dimensional architecture is as shown, which uh, incorporates ReLU, dense, flatten, as well as the convolutional 1D layers. Here, X is the input data, that is, for dataset 1, we input VHI values, while for dataset 2, we input the merged VHI, that is the concatenated VHI, as well as the rainfall values. And finally, we get Y, that is the predicted output. Lastly, I'll come to the random forest model. The formulation for random forest is as shown here. We give input for dataset 1 as the VHI values, as well as for dataset 2, that is the merged VHI plus rainfall values. And we calculate Y, which is the average of all the random forest trees values. Now, I'm going to talk about output for the dataset 1. We can see here that for MLR model, the R2 score is the highest, as well as the R2 score decreases for RF and subsequently for the MLP model. Similarly, the MAE as well as the NSE, that is the absolute error as well as the mean square error, is the lowest for MLR model, while it increases for MLP models. For dataset 1 again, we can see that KNN has a good R2 score, that is 0.941, while for 1D CNN and SVR, the R2 score further decreases. For dataset 2, that is the VHI and the rainfall data, we have MLR model with an R2 score of 0.96, while RF and MLP show a less R2 score. Similarly, MAE as well as NSE is least for MLR model. We can also see that further, KNN model shows less MAE as well as NSE compared to the multivariate linear regression model, as well as the R2 score for KNN model is the highest in this case. Now, I'm going to talk about the comparison of the models here. So for comparison, we use the performance matrix, that is mean R2, mean MSE, mean ME, as well as the computation time. These are the values that have been jotted down in the table. The computation time for random forest is the highest, while it is the least for the KNN model. These are the predicted route maps for dataset 1. We can see that for Rajasthan 1, the shape of the Rajasthan region is 192,256, and similarly, it is for the route maps. These are the predicted values that have been plotted for all the 6 models that we have used. Further, these are the predicted route maps for the dataset 2 that we have used.
You have less than 5 minutes time.
Now I'm going to talk about the analysis section. RF and MLP models, they have a complex architecture with numerous parameters. RF has multiple decision trees, which has high computational time, resulting in large number of trees. MLP is characterized by multiple layers and neurons, which introduces an abundance of weights and biases. On the other hand, models such as MLR, KNN, SVR, 1D, CNN, they have a simple architecture with enhanced computational efficiency. MLR is a straightforward model with only input and output variables. KNN has reliance on nearby points, which aligns with the frequency patterns observed in droughts. That is why it is able to capture the accurate points for the drought prediction. SVR has a model architecture which involves only dot products and addition operations. Moreover, user-defined error boundaries make it robust to outliers. 1D CNN also has a simple model with only single convolutional layer. Now, finally, let's come to the conclusion. Here, we have presented a comprehensive analysis of drought prediction models, which focuses on Rajasthan region of India, using 2 datasets, majorly VHI and VHI plus rainfall. Simpler models such as MLR, KNN, SVR, and 1D CNN outperform complex models like RF and MLP across all time scales, that is 1 to 4 weeks. MLR attains the average R2 score, while the lowest MSE, that is mean square error and mean absolute error for VHI dataset, while for dataset 2, KNN exhibits the highest average R2 score of 0.93 and least MSE and MA of 0.005 and 0.036 respectively. Thank you for the presentation. We'll now be open to any questions.
Okay, thank you very much. 3 minutes time left. Pak Iqbal, Muhammad Iqbal Habibi has already raised his hand. Please ask yeah, your question, please.
Okay, thank you, Ms. Dr. Endang. So I was interesting for your presentation. So your parameter that you use, that PHI,
Yes.
did you compare with the P, P, PCI? So that's the first question, because the drought also PCI is the mostly used for the drought parameter, because you use the PHI in here. And then second question is, how do you measure the duration, the for each the parameter that you use for your model? So MLR, so 1 week, 2 weeks, 3 weeks. Did you average them into your duration, or something that behind the scene? Okay, thank you very much.
Okay.
Okay, so I'll
So for the
start with
first,
first answering
yeah,
the.
yeah, sure, sure.
Okay. Yeah, so I'll first start with answering the second question. So in the second question, like we have the weekly data that has been taken from the downloaded from the website. So that weekly data, if we want to predict weekly values, then we'll shift that data by 1 week. So the VHI labels will be 1 week shifted labels. So this is how we'll be able to predict the weekly values. Similarly, for 2 weeks, we are going to shift the weekly data, that is VHI labels by two values. So shifting by two values will give us the output that is of 2 week prediction. Similarly, it has been done for 3 weeks as well as 4 weeks. I hope that answers your question.
How about the
Yeah.
PCI, that it can be measured in the Landsat also, not only the star NEDIS? Did you elaborate that? Uh,
Are you
this
saying a comparison with only VCI, like vegetative condition index?
Yes, I mean that you use the VCI is only for the star. Did you measure using the Landsat 8 also?
What have we? I don't understand your question clearly. What have we measured using Landsat 8?
No, I mean PCI can also be measured in the Landsat 8. Yes,
Okay.
yeah, but you only measure the TCI. Why don't you measure the PCI also in the Landsat 8 for
Uh,
comparing the in the PHI also,
so we
so you
so
can get the same?
Okay, so this analysis is presented only based on VCI and TCI. It is not presented based on the PCI. And honestly, there is no specific reason to exclude or include PCI that we had thought of. But we were very clear about a few things, that we want three different kind of factors in an analysis, which is one should be from the remote sensing, which is VCI. One should be from the ground level, which is TCI, and the third should be the rainfall data. So these were the three factors that we were pretty sure about, that we surely want in an analysis. That is why we have incorporated those. But thank you so much for the suggestion, and we'll surely think about incorporating PCI also in the further works.
Okay, thank you. So the StarNetDis is a satellite system also.
Sorry.
The StarNetDis, NESDIS, is it the
Yes.
So
where?
StarNet is basically a website, and the satellite system is basically NOAA.
Oh, okay.
NOAA.
Yeah.
Yeah,
Noah, from the Noah.
yeah, NOAA.
Oh, okay. Thank you
That is
very
a
much.
series of satellites that we have.
Yeah.
Yes. Okay, because most is using the Landsat, Sentinel, or MODIS, but I haven't hear from the StarNetDis. Thank you very much.
Okay.
Okay. Thank you. Thank you,
Thank you.
Mr. Sayal and Mr. Akash. Thank you, Pak
Thank
Iqbal,
you.
and thank you for your presentation. It's nice presentation and interesting topic. Thank you.
Okay. Thank you so much.
Thank you.
Thank you.
Happy to present.
Okay. Now we go to the fourth presentation. Back to Pak Iqbal. Hold on. No. I'm sorry. The fourth presentation is coming from the paper titled Optimizing Air Quality Forecasting with Multivariate Linear Regression, Research Innovations and Implications, written by Ms. Somesh Sharma and Amit Mittal. There's one of the author already here. The committee, they are not here. Okay, then we can go directly while we're waiting for the fourth presentation. We can go to the fifth one, and the paper with title Air Quality Monitoring in Indonesia. Mr. Iqbal Habibi, you will present that paper.
Okay.
Okay.
Please wait.
If you're ready with your presentation. Oops. Not that one.
This one.
Yes. Okay, 20 minutes. You can start your presentation.
Okay, welcome back again. So it's a, it, it is a glad to be in this second presenter again. So I would like to present my research with my team. So the air quality monitoring in Indonesia. So I'm Muhammad Iqbal Habibi with this amazing team. I'm from the National Research and Innovation Agency. Okay. So this content will be presented in 4 sections. The first one is introduction, methodology, result, and discussion, and conclusion. So as you know that nowadays is the pollution is the most the most dangerous and environment concern. So usually pollution is caused by the chemicals, metals, labor, land, water, and air. So the air pollution can be leading as a cause death from this poison. So the variation in location and time can be composed of various source of gases and particles that contribute in the air pollution. So also the air pollution can base from its source, chemical composition, like before, also location emission and intensity. So the air pollution is can be classified as the primary or the secondary based on its source. So the pollutants classified into 3 types: the particulate matter, PM, carbon monoxide, CO, and sulfur dioxide, SO2. The secondary pollutants are produced by the chemical interaction between the main pollutants and gases. So and also the second pollutants is include the nitrogen oxide and ozone. So the air pollution can be either in outside or inside, it depending on its source. So like the storm, forest fire, and volcanic activity is some examples for the natural occurrence that generate the pollution, along with the urbanization and industrialization are the primary sources that anthropogenic air pollution from the power plants, industry, and automobiles. So based on the World Health Organization or WHO, so the 92% of people worldwide is exposed to the poor air quality. So from this WHO data, nearly the people on Earth, 99% breathe air that high, includes the high level of pollutants and exceed from the guideline limits. So they have a parameter low, middle, and income nation usually hit the this pollution. So this so as you see this figure, so we saw the from the industry and energy supply, dust, transportation, waste management, and industrial practices and household energy. This can be as the source of air pollution. So this from the WHO. And then the methodology that we use first is the air quality monitoring. So we use the Sentinel-5P from the satellite image that we categorize into two. Is the offline that we use and near real time or NRTI. And also we use the composition of the atmosphere. So the atmosphere, we break down the elements into the carbon monoxide, formaldehyde, methane, ozone, nitrogen dioxide, sulfur dioxide, cloud cover, and aerosol index. So the nitro oxide dioxide is sourced from the car emission, industrial operation, and combustion process. So the ozone or O3 is a indication from the air quality interaction between sunlight and pollution. And second is the sulfur dioxide is contains the gases from the fossil fuel and burn. And carbon monoxide is emission from the automobile and industrial activities. So formaldehyde is a colorless gas, so it cannot be seen, but it is a combustion from the process and industrial operation and natural source. And also methane is from the agriculture operation that we saw the figure before, and then digestion, fossil fuel, and also some natural processes such as wetlands and termites. And aerosol index is from the dust storm, volcanic eruption, pollution, and natural calamities. And lastly, we see the cloud cover also as our monitoring in our system. So beside the air pollution, we define also some diseases like indicator from the corona disease like in 2019. So some disease we in our country disease of zoonosis is built in the One Health in Indonesia. So they say that more is from the DBD or dengue fever and malaria disease, anthrax disease, canine disease, bird flu, and Ebola disease. So this is most widely disease in Indonesia, mostly factor in Indonesia. Then in 2020, corona disease zoonosis became popular like 3 years ago. So we confirmed that in our country is 80,782,000 that has a cases of COVID-19 in the last 30 December 2020. So it affects 221 nation and 180 local transmission countries. So this table I get from the Ministry Health, Corona in 2020. So mostly this Corona disease spread mostly in the DKI Jakarta in 2020. Nowadays is increasing this about 2,000 more in 2023. So we in our research, so we build an idea to build the air quality. So we build using the Google Earth engine. So we using the titles, color palettes, and province label and legend, and then we can integrate that this parameter of each of our composition atmosphere. So it's that we conclude that in the system from a year ago until last this one I took 20 November 2022. Okay, firstly, we can see the atmospheric composition, so the dioxide and sulfur dioxide and formaldehyde. So we can see that dioxide is concentrated in Sumatra and Papua region. So, and also sulfur dioxide, I mean, SO2 is concentrated red in the Java Island and is indicated in the red color. So, and formaldehyde also in Jakarta and also southern of Papua region. So mostly industrial formaldehyde can be seen in Jakarta and Papua is when we saw this composition, a compound. And then next is the carbon monoxide and ozone. So this carbon dioxide is almost similar, but this is roughly, there is some cloud if there is a carbon monoxide concentration. So the range is 0.016 until 0.0608 so for the concentration. And then the ozone is concentrated also 0.1076 until 0.121. So the highest concentration and ozone is located at the southern area because this show figures is high indicator is a yellow for this compound density. And then for the methanes or CH4, highest in the Indonesian eastern part in this region. So we can see this brown color can be concentrated as the methanes in Sulawesi and a bit of Papua Maluku area. And then the aerosol index, also we calculate that is in the cyan color. So we indicate the medium aerosol levels in dark blue. So the dark blue show the low aerosol level. So the highest is in the light blue color. So, and then also we concentrate also the cloud refraction from where the weather is affected. So zero represent there is no clouds. And then after that we compare and detect the detection of the coronavirus. So when we calculate that, the air quality that from the nitrogen dioxide that we detected the corona disease is based on the nitrogen dioxide. So mostly in the Sumatra and Java Island and part of the Kalimantan, Sulawesi, and Papua. When the lockdown begins at that time, this area, this green color is disappear. So it's not some people is at the houses that so the disease is not spreading well. So this is we can define in the nitro dioxide during the lockdown. Okay, so the conclusion that we in our research, we find that the atmosphere composition regional in Indonesia, we use the 8 criteria like carbon monoxide, formaldehyde, methane, ozone, nitrogen dioxide, sulfur dioxide, cloud, sulfur, and aerosol in Papua, Sulawesi, and Sumatra, mostly polluted in atmosphere. So and also is concentrated in the high concentrate of sulfur dioxide is Papua area and Jakarta because there is uh, the industrial area that we saw before. And this carbon monoxide and oxygen is range this one. And then its important parts is concentrated in Sulawesi as the highest level of methane. And also the Java Sea covers various, it depends on the weather that we can see the cloud cover and aerosol level is medium as that part. We can see different part in each year for the aerosol level. And also we, from figure 10, before we identify the coronavirus based on the nitrogen dioxide. So most cases in the Jakarta, about 1,800 no, 181,713, then followed by East Java and West Java, then Central Java. So this successfully system atmospheric concentration can measure eight demands or criteria. So this application can be used and evaluated for atmospheric research and decision making. Okay, that's all. Thank you very much. I hope we can have a great discussion. Thank you.
Thank you, Pak Iqbal. Still more than 4 minutes, a bit more than 4 minutes. Is there any question from the audience? One or two questions. Okay. You use the data from the beginning of the pandemic time, right?
Yes.
Is it? Yeah.
Yeah.
And that was in 2019 or 2020?
That one is the 2019 beginning.
2019 probably, if I'm not mistaken. But you didn't get, you didn't use the data from 2019.
No, I just compare the lockdown then time. So, but we can
From
get
the
the distribution of 2019 from our system is almost matched with the Ministry of Health.
So you used it well, but you don't you didn't show it in the on the paper. You didn't put it on the result on the paper or something.
Yes.
Is that what you're saying? Okay.
Yes.
So it's similar. The result will give a similar
Yes.
I mean,
Yes.
okay. 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 Is there any questions? Still 2 minutes. Okay. Then if there is no other question, thank you very much, Pak Iqbal.
Okay. Thank you.
Yeah. We can go to the next one. Oh, hold on. Is there any presenter from the fourth paper, the committee? And there are also no in the main room? No, okay. Then we can go to the last one, last presentation paper with the title Field Survey of Paleo Tsunami in Bengkulu, written by Purna Sulastya Putra. Pak Purna Sulastro.
Yes.
Okay.
Yeah.
Oh yeah. Okay, Pak. Are you ready for the presentation? The
Yes.
PowerPoint?
Okay. I will share.
Okay. Okay, you have 20 minutes presentation and also the question and answer session. You can start your presentation, please.
Okay, thank you. Good afternoon, ladies and gentlemen, and thank you very much for the chair for this opportunity for me to present our actually our very preliminary result of field survey of paleo tsunami in Bengkulu, Sumatra. So on behalf of this college, I will talk about this result. So the main problem in Indonesia is that the historical record of tsunamis is very short, and tsunami recurrence interval are long. So sometimes the historic record of tsunami is not enough for tsunami hazard mitigation. So we need a paleo tsunami study. So what is paleo tsunami? Paleo tsunami is tsunami occurring prior to the historical record or for which there are no written record. So uh, why paleo tsunami? Because we need to answer some question like where will be the tsunami, how big, and also how often the tsunami in an area. So we need to use the geological data to answer that. So that we can, for example, we can understand the tsunami behavior based on the uh, deposit of the tsunami, and also we use the data to calculate the tsunami recurrence interval, and also to document the tsunami hazard. And why Bengkulu? Because previously no paleo tsunami studies in Bengkulu, and also in general in Indonesia, like I said before, we have very short tsunami historical record. So did tsunami leave traces or deposit? Yes, this is example of tsunami deposit from the 2004 Indian Ocean tsunami in Aceh. So we can see here that online this area covered by this brown to yellow or white sediment, which is the sediment that deposited by the tsunami. So then during the geological time, this sand or sediment deposited by tsunami will be buried or covered by soil, and then it will be preserved as paleo tsunami. But not in many area, paleo tsunami will be preserved. So we need to find good area to identify or to explore the tsunami deposit, an area that the layer of paleo tsunami will be preserved. So this is example of a layer of historical tsunami and paleo tsunami in Aceh. So this uppermost layer, this white, is the deposit of the 2004 tsunami, and then this white layer Selawah 1839 it is not paleo tsunami, but it is ash layers from Selawah volcano. And then we also have actually very thin sand layer here. Probably it is deposited by the 1907 event, and then we have this white layer below the Selawah ash, probably from historical record in 1797. And we have another this white sand layer in between this pit or black layer. We don't know. Probably this is paleo tsunami because it is not written in the historical record. We also have another sand layer in the lowermost part of this trench, but we don't know which tsunami deposited this layer. So we hope that we could find this very good layer in Bengkulu, but maybe what we found will be not like this. So I will explain later. Okay. So this is the general methodology for paleo tsunami. So usually we make a trench, geological trench. So we digging in an area that possibly we can find and identify paleo tsunami, and then we also use hand auger for coring the sediment, and then we describe the stratigraphy. Sometimes we use the bigger tool for coring, and also we measure the detail topography by using differential GPS, and also we trace the continuity of the layer by using geophysical method. But not all
Sorry,
of this method we use.
Pak,
Yes,
Pak Purna. Your
yeah,
slides
look.
is still on the first
I'm
page.
sorry. Okay, okay. I will stop share. So is it still first page or not?
Yes, yes.
Already moved?
No.
Oh no. I don't know. I'm sorry.
Yeah, just move from there. You don't have to. If you can't move your slides, then you don't have to use the slideshow mode. But then, yeah, from here, yeah, just use that.
Okay.
Yeah, yeah, just like that. Yes,
Okay.
that's better. Yeah.
So
Okay.
yeah, I'm sorry the trouble. So okay. So I will uh, talk again from this slide. So this is an example of Palay tsunami layer we found in Aceh. So this uppermost white layer below the modern soil is the 2004 tsunami deposit, and then we have another other apa, white sand layer that possibly deposited by older uh, Palay tsunami or historical tsunami. So we found the historical tsunami deposit of 1797 and also 1907, and we found here beautiful sand layer that probably deposited by Palay tsunami. We don't know which tsunami this sand layer came from, and also we have another in the lowermost is this white sand. This is also possibly older Palay tsunami. So we hope in Bengkulu we can find these layers in our survey area. And this is the methodology we use. So in this red block, this is the methodology we applied for our survey in Bengkulu. So we conducting geological trends by digging in an area that the Palay tsunami possibly preserved, and then we also coring the sediment by using hand auger, and also describing the stratigraphy, and also taking some sample for laboratory analysis. We also yeah, in other area we use this differential GPS to measure the detailed topography, and also using some geophysical method to trace the continuity of the paleo tsunami layer. And then so this is our area in Bengkulu. So we have three main areas in the southern part of Bengkulu, in Bengkulu City, and also in the northern part of Bengkulu. So we will move in the first area in Alam area in Kabupaten Seluma. So in this this blue box is the area or the location that we found our first candidate for paleo tsunami layer. So this is the the data we found there. So this is the core. It is not so clear in this picture, so I draw this composite stratigraphy in the right side. So the stratigraphy is like this. The uppermost is the modern soil, and then we have a pit to PTCL layer. It is a dark brown to black, and also sometimes we found wood fragment. And interestingly, we found this sand layer in the depth less than 1 meter or around 1 meter, 80 centimeter to 1.2 meter. Uh, this sand layer continues in some core. So we believe that based on this distribution, it is deposited by uh, paleo tsunami. And also another evidence is that in this sand we found some foraminifera. So foraminifera, this is the picture of foraminifera, is a microfauna that only found in marine. So the occurrence of this foraminifera in the land environment on land. So it is interesting. It is evident that this came from sea transported to the land. And then in the second location in northern part of Bengkulu City in Nusa Indah, we coring in the area of paddy field. So it is very wide paddy field, and it was soil or depression in between the high area. So it was probably uh, kind of lagoon or swamp that now become paddy field. So the stratigraphy in this area is like this. We found the uppermost is the layer of rice field, and then we found sometimes it is to pit, but not so thick. But the dominant in this layer is actually clay that contains some fragment, possibly flat deposit. And then underneath this, we found the pit that contain this sand layer that possibly our paleo tsunami layer. We trace this layer in some cores and up to almost 400 meters to the land, we still able to observe this sand layer. So it is uh, we more believe that this is our candidate for paleo tsunami because of this distribution. And at other location, the paleo tsunami was not identified because mainly in coastal area in Bengkulu, the land already used for palm oil plantation. So possibly the preservation of paleo tsunami already disturbed by this palm oil plantation. And then in many areas, not like in Nusa Indah, we found a very thick pit, indicated that the environment that uh, paleo tsunami can be preserved probably not developed in other area, because when we coring the location, we only found the modern soil and very thick sand. The sand probably is the old bit sand, so it's mean that the soil condition is not developed. So if the tsunami came and deposited material in the pits environment, it is not easy for us to identify the paleo tsunami, and also it will be not good preserved. So that's why we not able to find many paleo tsunami in many locations in Bengkulu. So this is our last slide. So conclusion is that based on field observation, two paleo tsunamis candidate were observed along the coast of Bengkulu. So on the first paleo tsunami layer identified at depth less than 1 meter in the southern part of Bengkulu province. In the second layer identified in the northern part of Bengkulu city at depth around more than 2 meters. So because the depth difference is quite big, so we believe that these two paleo tsunami deposited by two different tsunamis. As this result that I present today is still very preliminary state, so discussion on the broader implication of this finding on the regional seismic activity and historical tsunami event is still very limited. And due to based on field data only, the interpretation of tsunami's magnitude and their correlation with paleo tsunami found in other areas of Sumatra, for example in Aceh, still cannot be done. That's all from me. Thank you very much.
Thank you, Pak Purna. Since the time is stopped in the middle, but yeah, I don't know what time left. But I give you a chance for another one or two questions from the audience. Is there any question from the audience here? You can raise your hand or ask the question directly.
No.
Yes, Pak Arifin, please.
Yes. Thank you, Madam Moderator. Um, I'm just curious, what is the drive for you to do a research such as this? Are you going to predict that there will be another tsunami, or what is really the purpose of the, what you call it, investigations of paleo tsunami in certain area? Actually, please explain.
Okay, thank you for the question. Yes, the main goal for our paleo tsunami surveys, of course, we want to know the history of tsunami in Bengkulu, because if we understand the history of the past tsunami, so we can uh, use the data for the basic data for tsunami hazard mitigation. For example, we know that in Bengkulu there were just say 10 tsunami along the last 1,000 years, for example. So then we can identify which one from these 10 past tsunami were the biggest, and also which one uh, that not so big, for example. Then from this data, we then also understand the recurrent interval of this past tsunami, which one or where was the last big event, the last of the biggest event that occurred in the Bengkulu area. So then we can understand or try to predict based on the recurrence interval where will be in the next tsunami. Of course, it is will not detail which year, so but probably we will understand in probably in the next 100 years there will be big tsunami, for example. So that's is one of the uh, main goal for this survey. Of course, if we can mapping its paleo tsunami layer, then we can understand the distribution of its layer. Then we can model the tsunami of its paleo tsunami, so we can understand how big was its tsunami. Just like that. Thank you.
Can, uh, uh, can you can you can you tell me? Sorry, Madam Moderator, I have to
It's okay.
question another one.
Yeah.
How accurate your inference in this case, or your prediction that there will be another tsunami, say around 100 years or whatever, without doing any more correlation study. For example, you may wish to do the same, maybe at certain another area which is perhaps not too far away, but still have a certain distance, which you may predict that it's going to be very much correlated paleo tsunami data that you might find. In such a way, then you could do some kind of refinement of the of your finding, something like that. What do you think?
Yes. At first, I'm going to explain again that this result that I present today is still in very preliminary result. So this is only based on the field survey only, and we actually we didn't know if this is correct paleo tsunami. What is the age? So we don't know yet until now. So of course we will uh, going further for laboratory analysis to understand all of that. So that after complete data from this survey, so then we can understand the recurrence interval, and then if we move to another location, for example in Lampung or in the northern part of Bengkulu in Rio or probably further again in Sumatera Utara. Then if we have all data, then we can correlate all paleo tsunami layer. So then we can understand this tsunami probably not affect the northern part of Sumatra. So this only occur in the southern part, or there for example, very big tsunami that affected in along the western coast of Sumatra that we have evidence from the paleo tsunami that we can observe in Bengkulu, in Lampung, in Sumatera Utara, for example. So that's the future goal for this survey. So this is only in the beginning. So yes, you're right that it is still not I mean we cannot talk much about this until now. Maybe that's my comment. Thank you.
Thank you and good luck, Pak.
Terima kasih, Pak.
Yeah,
Yeah.
still a lot of tasks to be done, needs to be done.
Yeah.
To know the pattern of our land.
Yeah.
Okay. Thank you very much, Pak Arifin, and thank you very much, Pak Purna.
Thank you.
Again, before we end this session, for the fourth presenter, is there a fourth presenter in the room? The committee? Still none? Okay. Then we can conclude our presentation for this room. But before we end this, could you please, all of us, turn on the video and we take a picture? The committee, can you take a picture? Yeah. Ada? 1, 2, 3. Okay. Thank you very much. We conclude this session by saying thank you and Assalamualaikum warahmatullahi wabarakatuh. Could you all please stay in the Zoom, because at the end of the session there will be a announcement about the best presenter. Thank you.